All right, hello and welcome. Today, we're going to talk about something that can be a real headache for Go developers, dealing with complex dynamic URLs. If you've ever found yourself fighting with the standard library, trying to pull variables out of your routes, then this explainer is definitely for you. We're going to solve this, and we're going to use a fantastic tool called Gorilla/Mux.
So does this whole scenario sound familiar? Your app starts out all nice and simple, but then it grows. And pretty soon you need URLs that are way more dynamic. You've got user profiles, you've got specific blog posts, paginated lists, and all of a sudden your once simple routing logic is starting to look like a tangled mess.
And here's the thing. Go's standard library is awesome for the simple stuff on the left. /users, /products, no problem. But our applications, they live in the real world, over there on the right. We need to be able to grab John and 123 right out of the URL, and that's exactly where the default tools start to get a little tricky.
So what's the actual problem here? Well, it's not that Go's built-in net/HTTP package is bad. It's incredibly powerful. It wasn't really designed to elegantly parse out variable segments from a URL path. You end up having to write all this clunky custom code to split strings, and trust me, that's a recipe for bugs and a nightmare to maintain later on.
I love this analogy because it makes it so clear. Go's default router is like a basic mail sorter. It looks at the zip code and throws the letter in the right general direction. But Gorilla/Mux, that's the advanced high-tech sorter. It reads the whole address, the street, the name, even the apartment number, and it makes sure that request gets delivered perfectly to the right handler, with all that extra information neatly attached.
So let's officially meet this advanced sorter. Gorilla/Mux is one of the most beloved and widely used packages in the entire Go ecosystem. And for good reason. It was designed from the ground up to solve this exact routing problem, and it does it with elegance and efficiency, all while playing nicely with Go's standard HTTP interfaces.
And getting started is about as easy as it gets. It's just the good old go get command that you already know and love. You just run this single line in your terminal, and the package is downloaded and ready to use in your project. That's it. No complicated setup, no hoops to jump through.
We're going to get this up and running in just 3 simple steps. First, we'll create the router itself. Second, we're going to teach it what our dynamic URLs look like by using placeholders. And third, the best part, we'll see how easy it is to pull that data from the placeholders right inside our handler function.
Okay, step 1. Instead of just letting Go handle routing implicitly, we're going to take control. We explicitly create our own router instance by calling mux.newRouter. We'll just assign it to a variable, let's call it R, and this little guy is now the new brain, the new traffic controller for our entire application's routing.
All right, now for the real magic. This is the core reason, the main event, for why I'd use a router like Gorilla/Mux in the first place. We're talking about effortlessly capturing those dynamic parts of a URL.
The secret sauce is this new syntax. Instead of a boring static string, we define our route using these curly braces. So title and page, those are our placeholders. It's basically us telling the router, hey, expect some variable text in these spots, and I'm going to need to access it later using these names.
So the router found the data for us. How do we actually get our hands on it? Well, inside our handler function, we use this amazing little helper, mux_vars. We just pass it the current request, and poof, it hands us back a convenient map of all the URL parameters it captured.
And this is exactly what you get back. It's just a simple Go map of strings. So for that request we saw earlier, you get a map with the key title and the value Go Blueprint. The key page has the value 10. It's clean, it's simple, and it's incredibly useful. No more manual string splitting.
Okay, so we've created our router, and we've defined a handler that knows how to read these URL parameters. Now for the final crucial step. We need to tell Go's built-in HTTP server to stop using its default router and to start using our brand new one instead.
I'm sure you've typed http.listen_to_server hundreds of times. But have you ever stopped to think about what that second argument, that nil, is actually doing? Well, that nil tells the server to just use the default global router. The simple mail sorter that only reads the zip code.
And here it is, the final piece of the puzzle. To activate our powerful new router, we simply replace that nil with our router variable, R. And that's it. That's the whole switch. Now every single incoming request will be handled by Gorilla/Mux, and all of our smart, dynamic routing rules will apply.
And here's what it looks like all put together. I mean, look how clean and readable that is. We import MUX, we create the router, define our dynamic route with its handler, and then we tell the server to use our router. In just a handful of lines, we've implemented a way more powerful and flexible routing system.
But honestly, capturing URL variables is just the beginning. It's like the entry-level feature. Gorilla MUX is absolutely packed with other features that give you incredibly fine-grained control over how you handle requests. Let's take a quick look at some of its other superpowers.
This is where you really level up. You can move beyond just routing by the URL path and start routing based on the nature of the request itself. You can say a route only works for post requests or only for a specific domain name. You can enforce HTTPS and even organize massive APIs using subrouters.
For example, you can easily chain the .methods function right onto your route definition. This is absolutely essential for building proper RESTful APIs. It lets you ensure one function handles GET requests while a completely different one handles POST requests to the very same path.
Well, what about this? What if you need to handle traffic differently based on the domain? With .hosting, you can route requests for api.mybookstore.com to one set of handlers and requests for www.mybookstore.com to a totally different set, all from within the same application.
And of course, security is critical. You can use .schemes HTTPS to make sure sensitive routes, like a user settings page or a checkout flow, are only ever accessible over a secure HTTPS connection. If an insecure request comes in, the router just automatically rejects it. So simple.
So, why does all of this matter so much? Because this one library lets you write code that is cleaner, more secure, and way more maintainable in the long run. It solves dozens of these common routing challenges, so you can stop reinventing the wheel and focus on building your application's actual features.
We've really only just scratched the surface of what Gorilla/MUX is capable of. It truly opens up a whole new world of possibilities for your Go web services. So the real question to leave you with is, with all these new superpowers, what complex and powerful routing logic will you build first? Thanks for joining this explainer.